Hi, everyone. Just a few minutes to let everybody join in. So please be patient and we will begin shortly.
Hi guys.
Just one more minute before we begin. Okay, let's get started. So before I clear the stage for our amazing speakers, Roy Ravon is the co-founding CEO of FinOut, and Commodore's own Nir Ben-Atar. He's a DevOps team lead. Both have loads of experience with infrastructure, cost optimization, reduction, and this is what we're going to talk about today. In the world of cloud, cost comes in different forms. Some of it is direct cost that you pay for usage, for cloud spend, for different tools. And some of the cost is indirect. You occur technical debt, you lose velocity, and many other things that Nir will dive into. And then we will take over and talk more about cost optimization from FinOut's perspective. So without further ado, let's get started. So let me hand over the mic to Nir Ben-Atar. Nir, take it away, and let's get started.
Thank you, Udi. I'm just going to get started with the presentation. Hi, guys. Can you guys hear me well? Udi, can you nod? Amazing. So, hi, very nice to meet you all. My name is Nir. I'm in Commodore for almost a year, and I'm going to start speaking this whole webinar in rhymes. Actually not. I'm a DevOps team lead in Commodore. I also do part of the backend team management. Roy is here with me as a CEO for FinOut. And we'll just get started with why accruing technical debt is actually a real deal and something that we must handle. So the first slide is Mark Zuckerberg saying move fast and break things, and this was the good advice. This was like the best best practice for us startups as we started to go fast, deliver features, break things, it's fine, fix it, growth, usage, adoption, scale. But then actually when you run fast, actually it has a price. You have to think about reliability and cost optimization and think about uptime and quality and all that kind of stuff. And this is something that you really need to take, put in effort to understanding what happens when you run fast. So before we start, I'm just going to talk a little bit about psychology lesson about a paradox called the region beta paradox. What essentially it means that people generally can sometimes be better off in a really bad situation rather than being in like a mediocre one. So a good example for this is like when you're in a relationship and it's like, okay, it's not that good. You're not very happy, but you're not very bad. And then you just stick into it and you're like in your relationship and you kind of take it slowly. But then if you're in a really bad relationship and you kept on fighting and everything was really bad, you'd probably think about breaking this relationship up and finding out hopefully a better partner and stuff like that. I think for this webinar, when we talk about outrunning your ability to do something, this could be a good time to actually think about the things that you're experiencing right now in your organization and to actually motivate you into doing something about it. So what are the signs that you run too fast? I think I listed down several ones. These are really just symptoms, and I'm going to go through them one by one. There are other symptoms. Obviously, when you run too fast, I'm just going to focus on these. The first one is when your dev velocity has really slowed down. So your dev velocity then is larger than your dev velocity net. Well, the velocity was faster than it is right now. Why does it happen, or why is this happening when you run fast? So we've all been in a greenfield project, and we started, and it was great, and we didn't have anything to think about, and we didn't have clients, and we could run and test and break things, and no one really mattered. But as soon as we have bigger clients that are needing specific things that are not exactly what we thought this service would do. So we add an if, and then this if just comes and bites us in the ass again after we try to solve a bug, and then there's a P0 severity affecting production. So your development velocity when you run really fast, you don't think about your quality, your code become fragile, you forget to add tests because you have to run fast, and then this essentially makes your velocity slower in the long game. So this is something that you really need to take. This is something that happens when you run too fast. A second point is when there's only one developer or engineer which can solve a specific issue. So it's very common for startups to have this one engineer that knows how to fix everything. In Hebrew we call him Shaga. But it's just that guy who keeps on fixing everything that's happening. And when we have this happening, it's like a double-edged sword, right? So we want to make sure that he's fixing things, and we get to production fast, and we solve the issues that are affecting our business really fast. But then everything, when he's the only one doing it, it's a single point of failure. So he can leave, or he can be sick, or he can be on holiday. And this can really affect our business. And also, obviously, this means that other engineers are not actually interacting with our code the way that we all want them to be. So we want the entire R&D team to be able to solve critical bugs. The next point is the fact that when we run fast, we really don't invest in the time it takes us to find root causes for really problems that are affecting a business. So when you run fast, you don't really put in time to add the right metrics or logs or APNs or anything which is not delivering features fast. You really run and deliver the feature, even when the quality is, you want to test it out, you A/B test, you make sure that it provides the MVP. But a lot of the time you forget about what happens when the service is down, or how do you track an issue for a specific customer. And then when this happens, you take a lot of time to find a root cause for production issues. Well, and obviously the worst time to handle a production issue is to add these logs or metrics or whatever is when you're in production issue. The last sign that you ran too fast is that you can't make sense of what is draining your resources. So you have your CEO, your finance, or anyone coming to you and saying, hey, what is this bill for Datadog? What is this bill for AWS? And you don't really have the ability to say, okay, yeah, it's because we scaled our DB because we had this customer join, or it's because we're trying a POC for a specific customer. A lot of the times you just look at the bill just kind of increasing and you're like, okay, I don't really know what this is. And this is obviously costly. And obviously for all of these things, once you actually have to handle them, it takes time. It takes time to understand, time to plan, and you don't want to be in any of these situations. So how do you really, what do you do in order to run fast? I believe that you have to, I'm all for running fast, but I'm for running fast with the right gear. And for me, running fast with the right gear, meaning that you have the right KPIs to measure and measure them as you run. So a good KPI for us is something that we do in Commodore is these 4 KPIs. One of them is the percentage of engineering teams solving critical bugs. So how many people are actually solving the problem? We look at this KPIs quarter by quarter, making sure that the percentage is above a specific threshold. And we adjust it according to the right reason. So if we had many people joining the engineering teams, we say, okay, if we don't, we have a threshold that we look in. And this is obviously going to help you make sure that your engineering team is really balanced and they all know how to solve those critical bugs and not just one developer. We take a lot of time investing in measuring our MTTR and MTTD. We use Datadog incident management for that. It really means how long it takes. MTTR, if you guys are not aware, mean time to recover or resolve. MTTD, mean time to discover. So how long it takes you to understand that you have an issue and how long it actually takes you to fix it. So whenever we have an issue, and we obviously have issues, everyone have issues, how long it actually takes you to understand that there was an issue. Do you have the right monitors? Do you have the right tools? Do you have the right knowledge? And then do you have the ability to be agile and push things to production with a short cycle time? And next KPI is how long it takes you to onboard and to activate. This is something that is really important for companies in this stage. So you have to do more with less, and you don't want to invest time for a senior developer to onboard a junior developer for a long time. So you invest in time in onboarding plans and tooling and make sure that you have all the right services so they can start actually providing value to the team. And you have to measure this. So if this increases over time, you want to understand that you actually are affecting your ability to run fast. The last thing is obviously looking at costs. We use multiple tools to look at costs and how these distribute, both for cloud providers, but also we really look into everything that the R&D department is paying for. So not just the big AWS or GCP or Azure if you're using it. So Datadog, BI platforms, that kind of stuff. So when you have KPIs, it's really important to have them, because if you catch these things that are drifting from your data point, you can handle them right at the spot instead of waiting for it to grow into big debt and then actually having to fix them retroactively, which obviously takes you more and more time. So this is why you should use KPI when you run fast. Thank you for this presentation. I'm sorry, this is me in a Britney Spears and with a title saying, "Oops, I did it again." Thank you, Woody. I'm just going to talk about a specific case study, because even though we run with KPIs, and KPIs are really important for us to pinpoint exactly what happens and to fix it at the time, we do actually come across issues where we have issues in our ability to run fast. So in Commodore, we had an R&D MTTD increasing in the last quarter by 20%. And when you do come across and you want to handle a tech debt, it's really important to ask why and to try to hypothesize together on exactly what happened. Is it a lack of knowledge by the other developers? Is it a lack of tooling? Is it lack of processes? And this is the kind of stuff that's going to help you to improve and to be able to run fast again. For us, we did encounter an issue where not all of our on-call engineers were trained enough. So we went on training for the on-call engineers, and we documented playbooks for all the P0s or the highest severity of the issues that could happen, and make sure that all of them had documented playbooks to do when they arise. We also used several tools that helped us to democratize knowledge around the specific area. So for databases, we've used Datadog database analysis. We added additional tooling, which will allow us to pinpoint issues that were in the root cause. So we added specific logs to those specific services which were actually happening. We made sure that all the metrics were on point. And we actually changed the entire process of determining who should handle which error. So we used to have one on-call engineer, which was effectively the point of contact for any P0 issue. And then we have area of responsibilities for specific areas in the system. So this is what you do when you actually have a tech debt and you want to handle them. You want to ask why. And the next thing to do once you actually added them is to make sure that you don't get hit by it again. So if you have an issue that was mitigated by creating a metric or a log, or an issue that you're currently facing, you want to make sure that you want to install a process which enforces APMs or logs as part of your definition of done for any other delivery. So this is what you do when you do actually encounter technical debt, and which will allow you to stop running as fast. What I'm going to do next is I'm going to show you a really, really quick scenario for how Commodore can make a developer actually save time by understanding a root cause of a specific issue in Kubernetes. It's not going to be too long, but I'm going to run through it really, really quickly. Can you guys see my screen? So this is Commodore. In Commodore, there is the concept of services. So this is my entire services. I can see really Kubernetes deployments and for my multiple clusters, and I can see multiple namespaces and such. I'm just going to zoom into a specific service where I actually have an issue. So it's painted as red and it's unhealthy. And it's unhealthy for a while. So what I'm doing right now as a developer is I'm zooming into understanding exactly what happened and what started. And once I do, I can see that there was a deploy and then a second deploy, and then really an availability issues, which started right here, which is still ongoing. So I can look at the availability issue and see that it's going on pretty much daily. This is a demo account, obviously. And I can investigate and understand exactly what happened for this scenario. I can get the logs for this, and I can understand, okay, from the exact beginning of this availability issue, and I can see that there is an error log saying my API rate limit is higher than the maximum acceptable size. I can get some pod health and latest deploy and all that kind of stuff. I do get some information about a latest deploy that happened 3 minutes before, and I saw that right here. So when I look at this deploy, I can see everything that's changed in this Kubernetes cluster. And this is really something that Commodore is doing for a developer to give them context of what happened before. In Kubernetes, you only know exactly what happened right now. And what Commodore is doing, which is going to help a developer to understand exactly what he did, is actually integrating with his GitHub and seeing all the commits that happened between these deploys. I see that guy actually deployed a commit, which actually changed the API rate limit from 800 to 2,500. And this was not in the actual config map. This was not in the actual deployment. It was actually in the config map, and Commodore actually understands the relations between resources in Kubernetes, which is going to allow me as a developer to actually understand exactly the root cause by just a couple of clicks, instead of actually going to my DevOps engineer and say, hey, I don't know, what is this config map? How is it related to my deployment? All that kind of stuff. So this is pretty much it for the demonstration. I'm going to hand it over to Roy for continuing for FinOut. Have a good one, Roy.
Thank you, Nir, so much for a fascinating talk. I'm happy to continue and give a bit more context on more stuff that starts to happen when you run super fast and break things. So you all know this common scenario, and I'm going to share a short story with you, right? So we're starting to migrate to the cloud, regardless of our cloud of choice. So it can be AWS, it can be Azure, GCP, ACI, OCI, Alibaba, whatever it is. And we try to utilize the basic services, right? So we're using a bunch of instances. We're using some databases, storage. So everything makes sense, and it's okay. But then we start to run a bit faster, right? So it means to start utilizing more and more services and start to buy some auxiliary services like Snowflake, like Datadog, and use a bit more, weird kind of or edge cases for managed services on AWS. This is where our infrastructure starts to get more complicated, and our cost structure starts to behave, a bit unpredictable, but still manageable. But the more we continue to run, the more services and usage-based price services and software we continue to buy. We see that different departments can buy like different tools to do the same kind of job. So oftentimes we can see Datadog and New Relic and Splunk in the same organizations, and for multiple clouds and multiple everything. And now we start to understand that there's a price for running that fast and breaking stuff, and the actual dollar sign price. So we start to spend like tons of hours on Excel sheets, starting to crunch some numbers and connecting the dots between bills from multiple different providers. Finance starts to constantly nag us with the implication of how much money do we spend on building our product, and we start to justify every invoice that we're getting from AWS. So now the AWS bill is up by 5% again. Great, but is this good? Is this not good? And finance demands answer, because really they can't understand anything that we did. And like we start to have tons of cloud waste, and latest of for Forrester survey mentioned that like 40% of the cloud instances are a level higher than what they should be, like a 2x instead of 1x, which means that we're like 40% of our instances are just costing us double than what they should have. And like the more of that we're accumulating, the more technology that we're using, the harder it is to start to right size. And it's very hard to start to create those accountabilities within organization, like to make sure that devs are actually care about what they're doing. So stop running, or it's a bit harsh things to say, but like we can start to be more accountable for what we are, and there's a bunch of tips that Fianot wants to share in order to deal better with cloud costs, so you can continue to run, but you can run more responsibly with your cloud expenses. So first tip is about observability, right? So same as Commodore is helping with Kubernetes troubleshooting, Fianot and its competitors are helping with observability data on terms of cost management. So it's the first thing you need to do, really, right? So Excels are amazing, and it's kind of probably the best product ever built, but Excels has its limitations, right? So it's very tough to maintain, and like very when it comes to multiple data sources in multiple formats, you need to do like a lot of work in order to get visibility. So now you migrated from AWS Athena to Snowflake. Great. So now you have another data source that you need to start to think of how to integrate into Excel, and things starts to change. And your developers are now changing the tagging schemes for a specific service, and everything is breaking. So it's very important to first like find a single source that you can trust, and make sure that it's the downstream service for every every service that you're using. All of the cloud providers, all of the solutions, as enriched as possible, including Kubernetes support, including everything that all technologies that you're using as a service. then it's important to start to create a single terminology within the company. So every developer, when talking about cost management, really understands like what are the basic paradigms and what are the basic stuff that that we're working towards optimizing. So we can we can optimize for specific unit economics. We can optimize for specific stuff that cost allocations that we have. And as long as we have like a common tongue in the organization, it's significantly easier to run those discussions. Tagging and labeling, especially in Kubernetes, which is super dynamic environment, is key, because like now we created a new deployment and it's running on clusters. It's like half of all the nodes in the cluster, and like no one knows who is responsible for it. No one knows what it does. And when we have hundreds of or thousands of developers trying to track to the specific Kubernetes deployment and why it's charging us so much money is an allocation nightmare. So force tags, force labels, so every resource has a specific set of predefined labels that it has to fill in order for us to track down on those costs and be able to show back and charge with them. And we need, the ability to start and answer the basics. So bills can go up, bills can go down, bills can remain steady. And if it went up, like, is it good or bad, right? So let's take Black Friday, is the most common example. Like everyone cloud bills throughout the planet is going up, but it usually is a good thing because we're servicing more customers, we're bringing in more revenue. But is it growing at the right amount? So, the 5% increase on the cloud expense when we have 10% increase on revenue is great, but 5% increase when you have only 2% increase in revenue, that's over provisioning. So it's a very thin line of doing that, and it's very important to do that. And we talk about cost optimization a bit later. Second tip is cost governance. So you can't let anyone do whatever they want. As giving developers the ability to do to ask any resources that they want, probably not gonna end up well. And we need to start to monitor our environment constantly. So we need to make sure that we have our playbooks and we have our guidelines of what's possible and what's not in our environment. So we need to track anomalies. We need to define the budgets. We need to forecast on cloud costs in order to be able to match really what's happening. We need to treat cost as if it's a first-party metric, right? So same as Kubernetes is crashing, I'm running to Commodore in order to restore the service, but why am I ignoring the cost spike? So right, the cost spike is really changing our entire financial model of the company, and it goes unnoticed. So we need to treat cost spikes as if it's a production incident, and make sure that we never gonna increase budget and not gonna get a request from finance in a couple of in 2 months, and now we need to trace back 2 months of dev work into what actually happened. And it's very important that this is implementing FinOps to its fullest, to give each team member in the company the ability to interact with cost the way that makes sense for them. So if they're an engineering director, they're a budget owner for cloud. So they need to be able to see how much they spend. They need to be able to track their own budgets. They need to be able to forecast. They need to be able to act on cost recommendations. If it's finance, they need to see the entire organization. And if it's the actual developer, they can see the cost for their specific service and make sure that they're responsible for that specific Kubernetes deployment or namespace. So every single person within the organization need to be aware that what it's doing costs money, and be able to consume those cost metrics. Tip number 3 is cost avoidance. So the best way to not spend money is to just not do it. And going back to developers, for example, if you're going to give a developer the ability to just run uncapped Kubernetes resources, they're obviously going to do it, right? It's the easiest way to build a service. Like, I don't care how much CPU do I need. I don't care how much RAM do I need. I'm going to request infinite kind of resources. My service is guaranteed to run perfect, and I don't care that the company is losing money. Like no developer would not say that, right? But if we're gonna force developers to start to think like, what are the boundaries of your service? Like, what memory do you actually consume? What's your CPU requirements? Let's optimize your service even before it's got into production and use resources and requests and limits. That way we can start to really create cost that is like very contained and very limited. Same with horizontal scaling, both on pods and the cluster level. So don't over provision your pod just in case you will need them at some point, and don't request like infinite number of replicas just because you may need it. Scale when when it makes sense, both on multiple pods and on multiple nodes within the cluster, and really manage Kubernetes cost. It's like often overlooked, but companies are spending money per instance for the cloud provider, but actually running pods and instances are just not the same. And you need someone to make that translation for you. So manage Kubernetes cost is like super important. Bonus tips, which is a bunch of unrelated stuff that we wanted to share with you guys. So get engineers to focus on their usage costs. So I mentioned and touched this point earlier, like engineers need to be aware of what you're doing. It's very important. It can't be understated. Like engineers really need to treat cost if it's a metric that they care about. Cost ambassadors is a concept that we saw working amazingly across different departments. So if it's with bigger organization, it's very hard to create that FinOps culture. So just find that one developer in the team that cares about it and makes him like the ambassador of the team. Try to to give him special swag. Try to give him like a special recognition for the company wherever it's possible, to be like the hero that actually saved money. And once other developers sees that we have that one ambassador that really cares about cloud costs, it starts to get contagious and start to get into a gamification. So they want to save money as well. They want to be recognized as well. And we started working with multiple organizations. It's amazing. It's a great thing to do, and we really encourage doing that. Optimization backlogs are like never ending, right? We always gonna find more ways to save money. We're always gonna find the opportunities to cut down costs and to re-architecture our environment to do that. And it's very important to keep like a tight backlog. So it's not we're not gonna stop everything that we're doing in order to optimize costs, but we can like get small tasks into sprints. We can start to prioritize them, and something that's really helpful is to give a dollar sign of how much money we can save for each optimization project, and make sure that we continue to optimize it with time, and we're selecting the lowest hanging fruits that bring us the most amount of money as the first task that we're running. And celebrate success. Developers are working hard in order to save money. We have companies that have dashboards of developers that save the most amount of money every week. So like celebrate it, like encourage it, make a culture of cost, like cost awareness, and it's going to work amazingly. Obviously I'm biased here, but it's very hard to achieve all of these without having a tool that can help you. So the cloud providers are great with starting to show their own tool, but a tool needs to be a bit more full in terms of how we can get the FinOps practice and service in place. So if you're interested, I would be happy to show you a demo of a bit of what FinOps is doing, and just to give a small tease of what we can do. So we talked about Kubernetes cost optimization, and when it talks about saving money, Kubernetes is usually one of the most expensive solutions, but there are also solutions that is really easy to optimize. And if we're going to start to monitor Kubernetes standards, especially like a request and for memory and CPU, so we can start to see like what's the usage over time of our pods and services. We know what memory, how much memory to request. We know what was the max usage of that memory, or even P90, and P80. Same with CPU. So request 1.5 cores, but usually we're just need 0.779. So we just change the Kubernetes request in the YAMLs, and we can actually give a dollar sign on that efforts. It's going to take few minutes of work, and we can save hundreds of dollars every month just in Kubernetes and the specific Kubernetes deployment cost. So it's really important to always think about it and make sure that we're having that level of thought within the organization, and we have a tool that can support us. And once we start to get into that culture, so companies can start to like really grab those costs before they're happening. We can find out issues on the fly, and we can create that culture of cost awareness within organizations. So tools are like a great way of doing that and running. And thank you so much. I think I'm going to pass the torch back to Udi to manage a Q&A of some sort.
Yeah, thank you, Roy and Nir. It was an amazing session. I hope everyone learned at least something new, at least one thing that they didn't know before. We will share the recording and slide decks with everyone, along with ways to contact Commodore and FinOut and Nir and Roy's social, so you can keep in touch. And if you have any other questions in the future, feel free to reach out. And do we have any questions before we close? We're almost at time. So let's see. This is your time. If you haven't already, you can drop your questions below in the Q&A. Or in the chat if you want to be cheeky. Okay, Jonathan AD says no questions. Excellent session. I agree. So if we're all in agreement here, so thank you. It's been great. And see you next time. Thank you, Roy and Nir, and everyone who joined us. Bye-bye.
Bye.
Guys, bye-bye.